Good, bright and beautiful morning, everyone. So, back to Tetris. Let's see. So, last time we left off, we were trying to figure out how to rotate, and we're unsuccessful. And we ended up just imploding a block on the screen, which was funny, but not helpful. So, I have spent some time thinking. I haven't done anything. I haven't touched it. I haven't written any code. I haven't looked anything up. But I have spent a lot of time, a couple days actually, trying to figure out how I should, approach this problem. So to kind of display my idea, we're going to need some sort of whiteboard. Whiteboard for the internet. Ha! Sure. Okay. So what I'm seeing in my head is you have to think of the block in its cells. So we have this block, and you can see I'm amazing at drawing, right? So here's our Tetris block. And so what we got so far was we were doing that math to figure out what the median is, right? And so the median is going to be directly in the center of one of these, of the block. All right, so I think here's my potential try at fixing this. So we have our x-axis here, right? And we have our, that was our y-axis. This is our x-axis. All right, so if we mathematically basically find the center block and then draw a grid, or draw this, these four areas, right, to it, then we will, then we can maybe potentially try to break this up. So here's my thought, right? So what we want to do is we want to measure everything that is to the left of this in distance. So this is 1, this would be 2, this would be 3, this would be 4, right? This is 0. Then we have positive 1, positive 2, positive 3, so on and so forth. So we'll just label the y's. We have here's 0, so this is positive 1. Then we'd have positive 2 and positive 3, and then of course negative, and that's kind of small, but essentially that's kind of what our grid looks like. So as you know, we have this. We're setting the shape of this block to 0, 0, yes, but what we want is relativity. So we kind of throw that out the window, and we just work on the relativity of it. So basically, we want to, the first thing, basically my idea is we measure distance from the x down the negative axis, or from the y down the negative x axis. And we figure out what that position is and then turn it into positive y's. So what that would look like is if we were to take this red block here and we'd measure that it is negative 1 x, we take that negative 1 x and turn it into a positive 1 x, or y. So a negative x becomes a positive y. And that works over here too. So we have this block here, right? So this one's going to stay in the center, right? And then we have this block here. So this is positive x. So a positive x becomes a negative y. So we say this is 1 negative x. So negative 1x becomes positive 1y. And then positive 1x becomes negative 1y. And so that's great for these 3 blocks. Now we've got it rotated here. And the real test to this is, does it work with this theory? So this block is located at what? -1 and +1. So -1, 1. Okay, so the theory is that this should work if we measure the distance from the x, so it's a -1x from the center, -1, so that means that it needs to be in the +1y. But it also has a positive x, and a positive x translates to a positive, or sorry, a positive y translates to a positive x. So if we were to do that, we take -1 and turn that into +1 for y. Then we take our 1 here, and since it's a +1y, we turn it into a positive x, giving us the block here at the coordinate plus, well, +1, +1. Okay, so the rule basically is that a -x becomes a positive y, and that a positive y becomes a positive x, a positive x becomes a negative y, and a negative y becomes a negative x. So this is basically the calculations that I'm thinking are what we are after. And remember, this is all relative, so this isn't our position or our shape. This is relative to these virtual lines that we're drawing in the code, theoretically, from the center point of the block. Okay, so the ultimate test, I would say, is to test this theory with another block. So if, let's open up another one so we don't lose that one, right? Yep, still have that one. So we're going to make our same lines, right? And then we have, say this is 1, this is, we'll just draw some lines out here. Don't really need that many, but okay. So the next, let's see, what's another block that we can try? We should try, how about, ooh, that's a good block. So we have this block here that looks like this. Okay, so we have this Tetris block. So we're going to take our same rules that we defined over here, and we're going to try to rotate that using the same rules. So this block here has a -x of 1 and a y of 0, so the y doesn't need to be translated. So the the negative x becomes a positive x, or sorry, positive y. Then we take, let's take the block up here since we just kind of destroyed it. We'll take a positive y and turn it into a positive x of 1. Okay, and then over here we take our positive x of 1 and turn it into a positive, or sorry, a negative y. And then of course the center block stays in the same place and we have a rotated block. So how does this look in code? And that's going to be the interesting question. So what we are going to do is we need to get rid of most of this. Don't know what I did there. Okay, we are going to get rid of that faulty bit of code that's there. And we are going to try to establish our rotation. Okay, so how do we define those rules? Well, let's just create a function. I'm not going to name it anything yet. We will figure out what to call it later. And so our rules are if, so we'll pass in, let's see, we'll just pass in a value, right? So if value, okay, this is, yeah, because now we're having to deal with both. We can't deal with just one at a time. So we'll do x and y, right? So if x is less than 0, that means it's a negative x. Let's see, what else do we need to do here? So we'll create two variables. We'll call it new x and new y, right? Because we have our old x and our old y. So if x is less than 0, then we will say new y is equal to, we need to turn it into a positive. So turning it into a positive would be basically x times, what's the trick? Turn a negative number into a positive number, you multiply by -1, right? So calculator, it was that thing in, in school that, so let's say we have a -2 and we multiply that by -1 and we get +2. Yeah. So if we multiply a number by -1, it changes from a negative to a positive, because a negative times a negative is a positive, and 1 won't change the value. Okay. So that works. Then we say if we have a y that is greater than 0, then we'll say new x, because we need to turn that into a positive x, is equal to y is equal to y, because we want it to stay positive, right? So I'm going to put comments of these here. These are going to try to represent what we have going on. So negative x becomes positive y, and then we have positive y becomes positive x. So positive y becomes positive x. See if I can line these up. Okay. Ooh. Yeah, x, positive x, and y. Okay, making sure. Then we have, what's our next rule? Positive x becomes a negative y. So x is greater than 0. Then new y will be equal to, so we're changing from a positive to a negative. So we're going from x to y, so x, and again times -1. We'll flip it. So positive x becomes negative y, and then if negative y, or if y is less than 0, then our new x is equal to y. And that is our rule. Negative y becomes a positive x. Oh, sorry, negative x. Which then the negative x is over here, and so you can see it loops down through and then would continue on. So we can rotate infinitely like this. All right. So I'm going to call this translate cell, and that's probably not the correct term, but we'll go with it. So I'm going to return a new object of x, new x, and y of new y. And that is going to be very useful for us. So what we need to do in here then, at that point, is, so we have our mid x and our mid y. So now we need to measure the distance. And we need to measure the distance from these midpoints. So we can get the distance. So we'll say var well, it's really the x difference, x diff, is equal to the, which way do we subtract? So we take the position of, no, we take the midpoint. Do we take the midpoint and subtract the x? So if this is, let's give these some real values. We'll use this one. We have purple. This one is, let's pretend that this is at 8, 7, right? Then this will be 7, 7. So it's a difference, it's a distance of -1 on our x scale. So if we take 8 minus 7, that's not correct. So it's 7 minus 8. And then, which would be -1. And then this block is 9, 7. So we take that block, 9 minus 8 is equal to +1. So you take the cell and then subtract the median, or the middle, the mids that we have here. So we take self.position.x, or are we dealing with this at the shape? We are dealing with this at the shape level. So we would say self.shape.x minus the mid x. Oh, but we need to do this for each cell. So not on so we need to do self.shape.coordinates for each function coord, and then in here we would do this. And so we take the coordinate.x yes, I think that's right, coordinate x, and then var y diff equals coordinate dot y minus the mid y. Okay, so then we test it out by calling, we basically want to kind of replace it, so we say coord dot x. Sorry, we'll do var result equals translate cell x diff y diff. And now we can say that coord.x is equal to result.x, and our coord.y is equal to result.y. And in theory, that should rotate our block. So what I'm going to do, just to make this simple, is I'm going to, easy to test. We could test it with code and just type it into the console, but that we know we already have a handler for doing key codes. I just need to do key codes. I just need to find the correct key code for the right key, and then we can just add that in really quickly. Oh, we are already using the right key. That's a terrible decision. How about we use, I guess we'll do the up key, right? Because we don't have anything on there at the moment. So we're going to do number 38. And so we go back to our project. And so we add another case 38. And this will be up. Then we'll call board blocks 0 move up. No, not move up. Rotate right on the board. Yeah, well, no, we don't need to pass in the board. Break. Okay. Well, here goes nothing, right? So press N, move the block somewhere, and then it disappears. So now we have a vanishing block. Cannot read property object of undefined. What happened? Okay, so now we know how to implode a block and make a block disappear. We are becoming magicians very quickly. We don't want index. We want, aha, what is this? Something happened here. Okay, so what we want to do is we need to find out what exactly was the issue. So I'm going to do the same thing. We're going to put a block on the screen, place it not outside the bounds, and press up. It calls our function, and now we're going to try to figure out what's going on. So we'll do mid x, mid y, x diff, y diff, and that's good for now. So if we step, we get a mid x of 1, which if this is 0, 0, this is 1, 0, so that's correct. And we get 0, which that's also correct, because y of 0, if this is 0, 0, then this is 1, 0, meaning y is 0, so this is correct. That's the right coordinate for that block. So now, so I don't skip over it, we drop in, and let's look at, we also need, coord x and coord y. So this is our 0, 0 block, which is this block. And what we should see is we should have an x diff of -1, which we do. And then we should have a y diff of 0, which we do. And so that result, well, let's place a breakpoint in here, confirm this is working. So we create 2 new variables, right? And so we'll put in x and y and new x and new y. Okay, so now if we step, we have an x of -1. So these are differences. So this would really be called diff x, or x diff and y diff. So we have an x of -1 and a y of 0. So this function should call, and our new y should become +1. It is. All right, so this should not call, so new x should not be set to anything. So what's happening, I think, is that our new x is undefined, and that is throwing us off. So we need to try to fix that. So the way to fix that is, if either of them are undefined, then we set them equal to what they originally were, which really the only things that could ever get through are zeros. So if so really it's just yeah, we'll just set them up here. So we say basically they start out as 0, and then if they never get touched, then they remain 0. Okay, so we made that change. We're going to come back here. We will unbreakpoint it. We will continue on. We will refresh, confirm our new code is in there. Yes, it is. And then we will press N. We will move the block down, and we press up, and it rotated. And we press up again, it rotated. Up again, rotated. So, not too bad, I would say. So the obvious thing to do next is to try it with some of the other blocks. So we're going to, where do we define our block? When we press N, nope, not those, unit tests. When we press N, we get a new block 1, 0, 18. So we want to try it with block number 2. So then we run the program. Press N, and now we have this one. So press up, and that looks good. It's a little, it seems to be kind of rotating on an odd axis, kind of strange, but it is in fact rotating, so this is a lot better than it was. Alright, and we'll just continue through most of them, make sure that they work in all of them, that and the fact that I've not actually put them on the page. Alright, so this should essentially do nothing, but it is in fact moving a little bit. I guess so this becomes its center point, and it just rotates around that. So I mean, there's still a little bit of stuff to kind of work on and make it perfect, but for the most part, I think we're doing a lot better. I mean, considering we don't have imploding or vanishing blocks. Press N, bring it down, bring it right, press up. That looks pretty decent. Okay. So then block number 5, refresh, press N, move the block. Yes, yep, that one works. And block number 6. Refresh, and need to fix that bug. That works. And block 7, and refresh, press N. And we get an error probably because block 7 doesn't exist. I'm assuming. Do we not have a set? No, I think we only have 6 blocks. Models. Well, we have a block 7, but it's at index 6. Okay, and the only block we didn't try it with was block 0. So we will try that last one before I go, and it also rotates, but very strangely. So this is kind of that extreme case. So there's still plenty of optimization that needs to be done, but we at least got a block going. So I again, like I said, I did not do any work outside of this video other than just standing around and thinking. And I thought about this problem for, like I said, probably 5 entire days, just as I was going about my day, or just standing around eating some food or making dinner or washing dishes. I find that I do my best thinking when I'm doing monotonous tasks. So, washing dishes, mowing the lawns, stuff like that. Very monotonous. You're not doing much. It's very kind of auto. You kind of auto. You're on autopilot. Maybe driving a car, things like that. Yes, I'm paying attention to the road, but I do think about these things a lot, and I do talk to myself as well, trying to think, okay, well, if this block does this, then how does that work here? And there was a lot of thought that went into this, but it just goes to show that, if you think about something long enough and you try to figure out a solution and be creative, be clever. I know that our first attempt, we just tried to we tried to find the midpoint of the block. And then we tried to do this, we just take the difference between these, and it made sense in one scenario, and it would have worked for the bottom 3 blocks, but that was it. This block goes up 1, right 1, and then it goes right 1, down 1. But I think this is a lot better way to go because it actually gives us the exact coordinate for the block to go to. So, that all being said, I think this was very successful. Do use your tools. Do come in and draw things. Get a napkin, get a piece of paper, get something. Just draw things out and think about the problem logically. Try to break it down in your heads and then get it in the code. Yeah, so that is block rotation in Tetris. Attempt number 2 successful. And I will see you guys next time.